Hello everyone, I'm Ausyellow and welcome back to the Science in Minecraft series. This is probably not going to be its name, I can't really think of a decent enough name. Do let me know of a good one in the comments. And today we are actually going to be calculating G subscript m, or the acceleration due to gravity in Minecraft of the player, or G subscript MP. Now, unfortunately, if I were to head into the F3 debug menu, there is nowhere that gives velocity, as far as I'm aware. They should really make that a thing, because then it would really help out this experiment. Also, up here with the coordinates, Lunar Client does not Lunar Client does not let you increase the accuracy of, or the number of decimal places, which is really annoying. Because it does for the speed or momentum mod, but it doesn't do it for position. So what I'm going to assume here, which really, if this assumption was false, ruins the entire thing, what I'm going to assume is that each frame, the speed that I am at that moment in time is the speed I'm travelling relative to the position at that frame at that moment in time, if that makes any sense whatsoever. So essentially I'm going to do 2 drops from 10,000 blocks, and I'm going to track the speed up to terminal velocity, and I'm also going to give an estimate for the y value at where that will be, and then I'm going to repeat the same thing again, but with eyes on the F3 debug menu. Now, without any further ado, let's go. Oh, actually, there was a bit of an error there because I had to... Right. Okay, I just thought of an error there. Right, same teleport command. Right, because I'm pressing space, I'm actually heading up a fraction, which is not really what I want to do. So, to counter this, game mode, survival. 3, 2, 1. There we are. Flight has been taken away instantly. We do not head back up. Those are the velocity values. What I will be doing is I will be plotting each value to 3 decimal places on my graphing calculator, just because I can get the initial rate, which should be 9.81 as the effects, it should be pure G as the effects of air resistance are negligible. I also have 41 levels. I didn't realise that. There we are. 7,500 blocks. Game mode. Creative. I would also like to try to find the rate of air resistance. However, I have not done the rate of air resistance at all in physics, which is annoying me, because air resistance in physics, maths and further maths is completely ignored. But I assume it works sort of like friction, which we might do some frictions, working out the coefficient of friction with ice, but essentially friction is Fr, the force of friction, or the force against friction, is equal to R multiplied by mu. R is the normal force, mu is the coefficient of friction. So therefore coefficient of friction is the force against friction multiplied by the divided by the normal force. I assume it works something like that. But also it might not as well. I think air resistance is relative to velocity, but this experiment should hopefully be able to find the rate of change. I could probably derive it actually, but anyway, game will survival 3, 2, 1, and there we are, decelerating at 7,500 blocks above the bedrock level. No, above the deep slate level, because that's now at y equals 0. I will head into creative mode, and the experiment should be over, but is there anything else I wanted to figure out? I don't think so. I just wanted to get values. What I will do as well is I will take more spaced out values, and we have hit the point right now. I'll take more spaced out values for this experiment to actually see how velocity is affected. Now, what we should get is we should get a graph that will increase and then plateau at 78.4 meters per second, with velocity on the on the y-axis and time. No, actually, calculating displacement, because I can't really time it. Ooh, oh, that's not good. How should we do this then? Well, how would you calculate acceleration? Well, given that v squared minus u squared equals 2as, v squared minus u squared over 2s equals a, and because that's like delta velocity squared, if we have, well, because the initial velocity is 0, it's literally just v squared. We can ignore u squared because that's 0. V squared, so the velocity, if we square all the velocity values and put them on the y-axis, divided by 2 lots of the distance values on the x-axis, the gradient of the graph would be acceleration, which I would suspect is a graph that would increase and then plateau at 78.4 meters per second, which could be modelled as... I want to model it as... Is that fire? Ooh. I could model it as an exponential, because, to be honest, an exponential seems like a better one to go for. But once we have the initial gradient, we don't want the final gradient. Once we have the initial gradient, we can then calculate acceleration due to gravity. But I really want to do air resistance, which I've got no idea how to approach, because... Bloody hell, you can waterlog leaves. I've got no idea how to approach air resistance because, I mean, I've ignored it. Well, I mean, we've been told to ignore it. And yes, I am putting out a fire right now. We didn't start... Oh, copyright. This tree is made of water. What the hell? Right. Problem solved. The lava can just live there peacefully. Because deriving it would... What would that do? Because it's a velocity over distance graph. What would that do, actually? I don't know. I don't even know if we should derive it, because we would have... No, we almost definitely want to derive it, because what we're going to have is we're going to have a graph that will increase and then plateau. Deriving that will give the rate of change of the rate of change, which should be decreasing linearly. And as it decreases linearly, the gradient of the decrease of the linear decrease should be the effect of air resistance relative to velocity. As none of this is scripted, I would just like to point out another error I made there. Deriving the velocity squared 2 times the distance graph would give the rate of change of, or like the acceleration due to gravity, which initially should be g, or on Earth 9.81, but because of air resistance it should change. This means if we take the second derivative of the initial graph, we'll find the rate of change of the rate of change, which would be the rate of change of acceleration, which the rate of change of acceleration should decrease to 0. That should be a linear graph, and the gradient of that graph, or the gradient of that linear, or the rate of change of the rate of change, should be the constant of air resistance. Why is this all important? Well, we're going to determine coefficient of restitution with slimes using velocity. Actually, one thing that just occurred to me, honey blocks. Are they bouncy of sorts? Actually, I want to make sure. Oh, no. Oh, that's a shame. But yeah, what I kind of want to do, the ultimate goal, is to make a simple formula with a bunch of with a bunch of constants in it that says if you jump from this height to this height relative to a slime block, in theory you should bounce up this height, because like in the last video we dropped from all the way up there at 320 blocks all the way down to negative 63, and we should have come up where is it, 229 or 242 depending on which coefficient of restitution you used. But we only came up -9, and that's purely because of air resistance. Now, air resistance would have to have some form of a factor in it, but I've got no idea how to graph it. What I'll have to do is I'll just have to work out G initially. I'll give the results on screen right now. I'll have to do it by frame, which would be horrible. I can also leave the correlation coefficient, R squared. For those of you who don't know, R squared is correlation coefficient. The closer that is to 1, the better the data lines up with the linear or polynomial graph that you decide to match it with, or like line of best fit. If you have data that's all over the place, the correlation coefficient will probably not follow a straight line, but if you do draw in a straight line, the data will not follow the straight line, the correlation coefficient will be quite small. And you want it to be 1. 1 is the highest, and we've been working with lots of 0s and 1s, and yet I can't stand coding, which is basically 0s and 1s in the first place. This is pretty much it for this episode. It's a very short one. I'm going to have to do tons of editing and maths. Please leave a like, comment and subscribe. Hit the notification bell as well so you can be updated on all of the new videos that are going to come out in this channel. And if I end up posting this before the big series thing that's going to come out, I don't know where I'm going with this. Thanks for watching, and just please subscribe. It helps out a ton. Okay, so using 9 pieces of data, including the start position, which was 0. This was very difficult, by the way. I got the rate of change or acceleration due to gravity, which started at like 20, then it went to 23, 25, 25.4, 25.6. It has come to rest at 25.627, give or take. And actually, I think that's deceleration due to gravity starting to kick in that early. Bearing in mind, we have only moved 3 whole blocks and are traveling at 13 meters per second. So yeah, I think that the acceleration due to gravity in Minecraft is 25.6 blocks per second, or meters per second. A block is a meter, essentially. R squared, or correlation coefficient, is 0.9998167, which is incredibly good. There is a systematic error, however, because the y-intercept is -1.677, which means it doesn't go through the origin.